Hello and welcome to another Korean College Scholastic Ability Test video. Today we are going to solve this problem, not just in one way, not in two ways, but in three ways. That sounds pretty exciting, so let's get right onto the problem. 12 identical, transparent, cube-shaped glass boxes are stacked in a configuration shown in bottom left figure. In this step, we intend to replace 4 boxes with black boxes with the same size so that the top view and the side view look like bottom right figures. So the top view appears completely black and the side view also appears completely black. How many possible ways are there to replace 4 boxes? And this is a multiple choice problem, so you have your choices right here. Like I said, I am going to present you 3 methods, but if you want to try this for yourself, pause right here, and for the rest, let us take a look at those methods one by one. Okay, the first method. Here we have this fancy title saying with only inclusions, choosing rows first, and you're going to understand what this means if you simply just watch this video. Suppose that we replace 3 or 4 boxes to black ones in the same row. For example, like these. So here we replaced the 3 boxes into black ones in the first row, and in here we replaced all 4 boxes in the first row. Then the number of remaining boxes that can be replaced in other 2 rows is either 1 or 0. So if we replace them, you can notice that there exists at least 1 row without any black boxes. This makes our desired side view impossible. Therefore, numbers of boxes replaced in individual rows must be 2, 1, 1, like this. First, we must choose in which row are we going to replace 2 boxes. There are 3 choose one ways to pick a row where 2 boxes will be replaced by black ones. Now, suppose that we chose this row as a row to replace 2 boxes. Now we have to choose specifically where we are going to replace 2 boxes in that row. There are total 4 columns, and out of these 4, we must choose 2. So therefore, for each previous case, there are 4 choose 2 ways to choose 2 boxes in that row that will be replaced. Alright, so far we have this. Next, in each of these cases, we must consider other 2 remaining rows, where only 1 box will be replaced in each row. In order for the top view to look like this, we must pick 2 columns that are unchosen in the first row, the row where 2 boxes are replaced. So how many ways are there to do that? For example, suppose we replace 2 boxes from the first row like this. Then, the boxes that must be replaced in other 2 rows are either A and D or B and C. So there are 2 ways of choice in remaining 2 rows. Therefore, the number of possible ways of replacing 4 boxes is, so 3 choose 1 is 3, and 4 choose 2 is 6, and we have times 2, so we have 36. And if we take a look at the given choices, we know that the correct choice is 4. Alright, now let's take a look at the second method, also with only inclusions, but this time choosing columns first. First, let us denote the rows and columns like this. 3 rows are denoted as R1, R2, and R3, and 4 columns are denoted as C1, C2, C3, and C4. What we want is the side view to look like this. Therefore, at least 1 box must be chosen in each row, and we can do that like this. We have 4 columns, so choose 3 columns out of these 4 and make an ordered arrangement with them. For example, like this. So first we have an arrangement C1, C2, C3, and in the next example, we have C1, C2, C4, and in the next one, we chose the same columns as the previous one, columns 1 to 4, but now in a different order, 2, 1, 4. Now for the first column number in this ordered arrangement, we replace the box at row 1 in that column. Then for the second element, we replace the box at row 2 in that column. And in the last column, we replace the box at row 3. So in the first example, we replace the box in the first row in column C1, then we replace the box in the second row in column C2, and then we replace the box in the third row in column C3. And in the second example, in the first row, the box is replaced in C1, in the second row, the box is replaced in C2, and in the third row, the box is replaced in C4. Finally, in this last example, in the first row, the box is now replaced in C2, in the second row, the box is replaced in C1, and in the third row, the box is replaced in C4. So now the question is, How many ways are there to do this? Here we choose 3 columns out of 4 and make an ordered arrangement with them. So we have 4 permute 3 ways, where this P means permutation. Okay, so far we have this. Now there remains an empty column which was not chosen previously, and thus none of the rows in this column is replaced with black box. But we must replace one box in this empty column, because only then we can obtain the top view like this. Here the condition for side view is already satisfied with these 3 boxes replaced. This means that we can choose any row in our 4th and currently empty column. Therefore, there are 3 choose one ways to pick a row in the empty column. So, are we done? Well, we are not done yet because of the matter of duplication. For example, consider this particular case. We can obtain this replacement in 2 ways. First, you can either choose columns C1, C2, and C3 in the first step, and then choose the row R2 in the remaining empty column C4, or you can either choose columns C1, C4, and C3 in the first step, and then choose the row R2 in the remaining empty column C2, which will obtain exactly the same result. Therefore, from here, we must divide this entire thing with 2. So we have 4 permute 3 is 4 times 3 times 2, and then 3 choose 1 is just 3, and we divide this entire thing by 2, so we have 36. Therefore, if we take a look at the given choices, we know that the correct choice is 4. Alright, now we will take a look at the third method, and it says with exclusions this time. We first consider the number of ways of replacing one box in each column, so that the top view looks like this. In each column there are 3 rows we can pick, and there are total 4 columns, so there are total 3 to the power of 4, which is 81 ways. Obviously, in these 81 cases, there are cases where the side view cannot look like this, so we have to exclude these cases. Now let's take a look at these cases. So the first case is when all 4 black boxes are in the same row, so that 2 rows remain unchanged. Here, all we have to do is to choose one specific row where all 4 boxes are to be replaced, so there are total 3 choose 1, 3 ways. Now the second case is when 4 black boxes are distributed in 2 rows, so that only 1 row remains unchanged. There are 3 choose 2 ways to pick 2 rows where the 4 black boxes will be distributed, and in these 2 rows, for each column, there are 2 rows to pick where the black boxes will be. This gives 2 to the power of 4 ways, or 16 ways, to distribute 4 black boxes in 2 rows, 1 at each column. However, these 16 cases contain 2 cases where all 4 black boxes are in the same row, which should be excluded. Therefore, there are 3 times 16 minus 2, so we have 42 ways where 4 black boxes can be in exactly 2 rows. So we have calculated the number of ways in these cases. Therefore, the final answer is 81 minus 3 plus 42, which is 36. And if we take a look at the given choices, we know that the correct choice is 4. And that's all for this video. Thanks for watching. Please hit that like and subscribe buttons, and I will see you in another video.